Hello and welcome to Math with Mrs. Becker. Today in calculus, we are going to look at some really cool application problems and how derivatives apply to the world of business and economics. Okay, so just some review right off the bat. When you're talking about the cost, okay, C of X, that's the cost of producing X units of a product. When you make something, obviously there are some costs involved. Your revenue, R of X, that's the money that you collect. So this is the revenue generated by selling the products that you created. Now your profit is how much you get to keep. So you take your revenue, the money that you collected, minus your costs. You pay your bills. Whatever you have left is your profit. Sometimes it's a loss, meaning you actually lost money. Okay, so profit can be positive or negative, but that's the profit generated by producing and selling the products. Okay, so cost, revenue, profit. They are defined only for non-negative integers because X is showing how many items you made. So they're integers because it's how many whole items you made, and they're non-negative because you can't produce a negative amount of items. Okay, so these work again for non-negative integers. Here is an example. We want to go ahead and maximize daily profit. A small sock shop sells Christmas socks for $3.50 per pair. The daily cost function is estimated to be C of X dollars, where X is the amount of Christmas socks in pairs sold on a typical day. So here is your cost. Okay, they gave us that. That's awesome. Find the value of X that will maximize the store's profit. We want to maximize profit. The only function that they gave us was cost. Well, we can go ahead and figure out revenue. Revenue is how much money you're collecting. They're selling the socks for $3.50 per pair. So the revenue is $3.50 times X. The cost, they're paying their bills. 0.0006 x cubed minus 0.03 x squared plus 2x plus 20. That's the cost. We want to maximize profit. Now, profit is defined as the revenue minus the cost. That's what the profit is. So if I'm going to find the profit, I have the revenue, $3.50 times x, minus the cost function has more than one term, so that's why I'm using parentheses. 0.0006x cubed minus 0.03x squared plus 2x plus 20. This negative needs to be distributed to every single term of the cost function, giving me 3.50x minus 0.0006x cubed. Negative times a negative, this is now a positive, 0.03x squared. Negative times a positive is a negative 2x. Negative times a positive is a negative 20. Now I need to go ahead and combine like terms. So I'm going to put this in the correct order. Negative 0.0006x cubed. I only have one term that has a power of 2, so plus 0.03x squared. X's, if I have 3.5 and a negative 2, I have 1.5x, then I have minus 20. Here is your profit function. Okay, so again, it's taking information about a real life scenario, making sure you could figure out what is the revenue. They gave you the cost, knowing how to find the profit, revenue minus cost. We went ahead and did that. They want us to maximize the profit. Well, if I'm maximizing, here we go. We need first and second derivative, you guys. So if I am finding the first derivative, negative 0.0006 times 3, because remember this 3 gets multiplied to the number up front, it's negative 0.0018 x, reduce the exponent, so now it is a 2. Plus, if I take 0.03 times 2, because this 2 gets multiplied by the 0.03, it's 0.06. Reduce the variable, so it's just an x. Plus, this would be 1.5, the derivative of negative 20, that would be 0. Now I know I'm going to need the second derivative to verify that it's a maximum. So if I go ahead and take 2 times negative 0.0018, I get negative 0.0036, reduce the exponent, so it's just an x, plus this would be a 0.06, this would be a 0. So I found the function, first derivative, second derivative. Now if I'm trying to find x, find the value of x that will maximize the profit. So I take the first derivative and I set it equal to 0. I want to know when the slope is 0. That means it's a maximum or a minimum. So negative 0.0018x squared plus 0.06x plus 1.5 equals 0. I need to solve. Quadratic formula, you guys. A is negative 0.0018. B is 0.06. C is 1.5. So if I go b squared minus 4 times a times c, let's go ahead and see what goes underneath the square root. 0.06 squared minus 4 times negative 0.0018, close it, times 1.5, and I got 0.0144. That's what goes underneath the radical. X equals negative b, negative 0.06, plus or minus, underneath the square root, 0.0144 all over 2 times a. If I take 2 times negative 0.0018, it's negative 0.0036. Next step, let's figure out what the heck that is. Square root of 0.0144, this equals 0.12. So I have x equals negative 0.06 plus or minus 0.12, all divided by negative 0.0036. Here are my two x values. That will maximize the profits of socks. You guys, all of this work to figure out how many socks should you sell. Negative 0.06 plus 0.12, that is 0.06, divided by negative 0.0036. Yeah, negative 16.6 repeating. Okay, let's try the minus. Negative 0.06 minus 0.12 divided by negative 0.0036, 50. Okay, so here are my two possible solutions. What x represents is the pairs of socks that you should sell. Well, you can't sell a negative amount. Remember they said that when we're looking at these problems, since this is profit, we're looking at non-negative integers. This is a non-negative integer. So if we want to maximize the profits, we need to sell 50 pairs of Christmas socks per day. Okay, so it says, find the value of x that will maximize the store's daily profit. We found 50. We want to make sure that, yes, that actually is maximizing. So I have to take the second derivative and fill in 50 just to make sure that we are maximizing. Negative 0.0036, 50 plus 0.06. If I go ahead and just fill that in, remember the value of the number, it doesn't matter necessarily what the number is. What matters is if it's positive or negative. Okay, I have negative 0.12. So at 50, that's when my slope is horizontal. This is negative, so it's concave down at that point. That means that this is a maximum. That's what we wanted. So 50 pairs. Then it says, what is the value of the maximum daily profit? So if I want to find the profit, I go to the original profit equation. I know that the maximum occurs when x is 50. So I take the profit equation and I fill in a 50. So let's go ahead and do that. Negative 0.0006. Instead of x, we're filling in a 50 to the power of 3. Plus 0.03, instead of an x, we're putting in a 50 squared. Plus 1.50, instead of an x, we're filling in a 50 minus 20. The revenue would be $55. So if you were the owner of that little sock shop, in a day, if you could sell 50 pairs of socks after you pay the bills, you'd go home with $55 in your pocket. Looking at that, I don't think I will be opening up a sock shop very soon. All right, let's look at the next problem. Now, things to remember. You have seen this a little bit, but it's always good to review. When you see the term marginal means to use the first derivative. Marginal means how much, whether you're looking at cost or profit or revenue, what's the difference when you add one more item from what you're producing right now? What happens if you have one additional item? Okay, the next thing now, this is really cool. If you are interested in business, you guys, this is so real life. This is the stuff that you'll study in college. There's something called a demand equation, and P represents the price. But your price is a function because you have to make calculations, okay? And so this tells you how should you price an item if you want to maximize your profits or if you want to sell a certain amount, okay? Because you want to look at the demand. So P is the price and it is a function. It determines the total revenue, okay, how much money you're collecting, if a business wants to sell X units. So here is your revenue. If you're looking at demand, your revenue is X. How many items did you sell times P? P is the price of the item. Okay, so it's the same idea. However, now the price is a function. It's not just like $5 or $3.50 like our last example. So let's go ahead and look at this. The demand equation tells you how to price the item. Okay, the demand equation for a certain product, let's say it's a latte, because lattes are fantastic. Okay, the demand equation for a certain latte is P equals 6 minus 1/2 X dollars. Find the level of production that maximizes revenue. Well, revenue is how many lattes you're going to sell times the price. The price is a function, so it's X times 6 minus 1/2 X. So here, when I distribute, here is your revenue. 6X minus 1/2 X squared. That is your revenue function. We want to maximize it. Well, when you want to maximize something, you need a first and a second derivative. So let's go ahead and do that. First derivative, this would be a 6. 2 times a negative 1/2 would be a negative 1. And you reduce the amount of your variable by 1, so it's just a single X. Now my revenue, I go ahead and I take the second derivative. This would be a 0. This would be a negative 1. So the cool thing is here, I see that this is a constant, so I know that this is always concave down. So I know that whatever value makes this thing equal a 0, because remember, you always take your first derivative, set it equal to 0, because that's where you want to find a maximum or a minimum. You want your slope to equal a horizontal line. You want it to be 0. Whatever I get here, it's automatically going to be a maximum because this is a constant concave down function. Okay, let's go ahead. 6 minus X equals 0. If I add the X over, 6 equals X. Okay, so if I want to maximize revenue, I need to sell 6 lattes. Well, how should I price them though? This is the price. So if I want to maximize, if I want to sell 6 lattes, the price needs to be 6 minus 1/2 X. X is a 6. So 6 minus 1/2 of 6 is 3. 6 minus 3 is 3. So if you want to maximize your revenue, you need to price the lattes at $3. Then you will sell 6 of them. Kind of cool stuff. All right, plus it's about lattes. Let's look at the next one. Okay, now here we're taking it a step further, okay? We're getting kind of into like the meat of calculus. They're taking the stuff that we've already talked about and they're turning it into real scenarios, okay? Well, let's look at this one. The WMA bus lines, they offer sightseeing tours of Washington, D.C. One tour is $7 per person and it had an average demand of 1,000 customers per week. So what that means is when they price it at $7, they get 1,000 customers per week. Well, they wanted to do a special, so the price was lowered to $6. Then the demand jumped up to 1,200 customers. Okay, so what happened is on average, typically the price was $7. They had 1,000 customers every week. They said, hey, Let's offer a coupon or something and have $1 off. So now the price is $6. They ended up with 200 more customers for the week. Assuming that the demand equation is linear, find the tour price that should be charged per person to maximize the revenue. Linear. We need to take this information and make a linear equation. So you guys, this is totally, we could go ahead and do 2 ordered pairs. X is the number of customers, Y is the price. So I had 1,000 customers when the price was $7. Then there were 1,200 customers when the price was $6. It's linear. We need to turn this thing into an equation. So you guys, we just jumped all the way back to the beginning of calculus. This is my x sub 1, y sub 1, x sub 2, y sub 2. Step 1, if you are trying to find a linear equation, you need to know the slope. The slope is the second y minus the first y over the second x minus the first x. 6 minus 7 is negative 1 over 1,200 minus 1,000 is 200. So that is your slope. Now to find the equation, you need to pick an ordered pair. Let's go ahead and I'm going to pick that one. Y minus the y from the ordered pair I chose. I chose a 6 equals m, negative 1 over 200. X minus the x value from the ordered pair I chose, 1,200. This is point slope form. Let's go into slope intercept. Y minus 6 equals negative 1 over 200x. Negative times a negative is a positive. 1,200 divided by 200 is 6. Now if I add 6 over, y equals negative 1 over 200x plus 12. They said the demand, assuming the demand equation is linear, this is P. Your demand equation is how do you price? So P equals negative 1 over 200x plus 12. That's how you should price the tour. Now let's keep going. It says find the tour price, so we need to find P, that we should charge per person to maximize the revenue. Well, you guys, revenue is X times P. So it's X times P is negative 1 over 200X plus 12. So if I distribute, here is my revenue. Negative 1 over 200x squared plus 12x. That's the revenue. We want to maximize revenue. So that's first derivative, second derivative. If I go ahead and I multiply this by 2, it would be negative 2 over 200. So that would be negative 1 over 100x plus 12. Second derivative, negative 1 over 100. If I want to find x, okay, x is the number of customers. What we need to do is take the first derivative and set it equal to 0. Negative 1 over 100x plus 12, set it equal to 0. If I minus 12, negative 1 over 100x equals a negative 12. Now here what I'm really doing is dividing, right? I'm dividing to get x by itself. But remember, you cannot divide fractions. So I keep the top the same, negative 12. I change divide to multiply, and I do the reciprocal of the bottom. So it's negative 100. Negative times a negative is a positive. 12 times 100 is 1,200. So in order to maximize your revenue, the money that you're collecting, you want X. X is the number of customers to be 1,200. The question says, find the tour price. Well, here's the P function. That's your demand function. It tells you the price. So we want to know the price to get 1,200 customers. Negative 1 over 200. X is 1,200 plus 12. Well, if I go ahead and I multiply this together, what I end up with is negative 1 over 200 times 1,200 is negative 6. Negative 6 plus 12 is positive 6. So you should price the tour at $6. You would get 1,200 customers. Then it says, we just want to make sure we answer everything. They have a lot of questions here. Find the tour price, $6. That should be charged per person to maximize the total revenue. Then what is the revenue? Well, you guys, here's the revenue right there. So now I can go ahead and fill in X. What is that maximum revenue? So the revenue, R of X, well here, this is even easier. It's X, 1,200, times P, P is the price. If I take 1,200 times 6, the revenue that you'd be collecting is $7,200. Okay, I know right now you're probably like, oh my gosh, I understand that's a lot. You have done all of these skills before. You've taken story problems and created ordered pairs. You've taken two ordered pairs and created a linear equation. Now they're telling you that that linear equation was the price. Your revenue is X times P. So I go ahead, I can find the revenue. You guys know how to maximize. You just find first and second derivatives. To find the X value, first derivative set equal to 0. This is a constant. That means wherever that was, because this is negative, it verifies it would be a maximum. So it's things that you've done, but it's just giving you a real life scenario, making sure you understand how it all works together. Let's look at one more. Okay, suppose that the demand equation for a monopolist is, this is the price. So the price is 100 minus 0.01x. The cost function, how much something cost, 50 times x plus 10,000. Find the value of x that maximizes the profit. We have the demand equation and we have the cost. We don't have profit. But revenue is x times p. I know what p is. So revenue is x times 100 minus 0.01x. So if I go ahead and I distribute, here is my revenue function, 100x minus 0.01x squared. There is revenue. Cost, they gave us, it's 50x plus 10,000. Revenue, or sorry, profit, that's what we want to do. We want to maximize profit. Profit, by definition, is revenue minus cost. So now I can go ahead and find that. Profit, I take the revenue, 100x minus 0.01x squared, minus the cost, 50x plus 10,000. Because the cost had more than one term, I need to make sure I distribute. So it's 100x minus 0.01x squared minus 50x minus 10,000. Here, my friends, is the profit. Negative 0.01x squared. 100x minus 50x is 50x minus 10,000. There's the profit. If we want to maximize the profit, first derivative, second derivative. So if I go ahead and I find the first derivative, 2 times negative 0.01 is negative 0.02. I had two x's, I reduce it, so now it's 1. The derivative of 50x is 50. The derivative of negative 10,000 is 0. Find the derivative of the first derivative, negative 0.02. Now, to find the value of x that would maximize the profit, first derivative, set it equal to 0. Negative 0.02x plus 50 set equal to 0. Minus 50. Negative 0.02x would equal a negative 50. If you take negative 50 and you divide by negative 0.02, you would get 2,500. Okay, so this is 2,500 items or units. So find the value of x. If I go ahead and I fill that in, right? This is where my slope is 0. If I fill in 2,500, this is negative, so it confirms, yes, this is a maximum. We got that, 2,500 items. And determine the corresponding price. Here's the price. The price is 100 minus 0.01 times x. X is 2,500. So if I go ahead and I calculate that, and I'm just going to put that in one time, 100 minus 0.01 times 2,500. The price should be $75, okay? And determine the corresponding price and the total profit for this level of production. Okay, so if we want to find the profit, we take P, and it's 2,500 because that's P is in terms of X. So here is P. If I go ahead and I replace all of the X's with 2,500, it will tell me the maximum profit that I can make. Negative 0.01, 2,500 squared plus 50 times 2,500 minus 10,000. Your profit would be, wow, 52,500. So in this scenario, whatever it is that you're producing, ideally, you want to produce and sell $2,500, each one priced at $75. After you pay your bills, if this happens, you would be able to bring this to the bank. Okay, you guys, so those are some pretty intense applications. I know you can do it. There are 8 questions in the book that are awesome. Okay, and there will be a Zoom call where we can do some of these together. So go ahead and give them a whirl. I hope you enjoyed digging in deep this morning, and I will see you later. Bye.